Yes, hello everybody. I'm quite happy to give you a presentation on the special subject of lighting and energy performance. And I am myself active also in TC 169, Light and Lighting, and which is responsible for this issue on European level, and also I am convener of Working Group 14, dealing with the coordination of the energy-related product standardization. So the situation of lighting is something which is in a way special, and that is also the reason that there is only one standard that is revised within the part of lighting. In lighting, we have the visual task, and it is very important that the lighting condition for this visual task are fulfilled. And above this, it is so that the lighting design is done in other standards. It's not part of the work done in this working group here. And also the products, they are standardized within Senelec, as we have electrical products. And there we have also in the part for the eco design, we do the standardization. So in the focus is the EN15251 from dated 2007, and this will be then revised as standard 15193 Part 1, and further on a technical report giving some guidance to this standard. Now, what are the main issues of this revision of the standard? The title, by the way, is Energy Performance of Buildings, Energy Requirements for Lighting. First of all, which is very important, is that we should take use of daylighting, and we know that the development is going towards that we have more and more dynamic facets. So these should be taken into account to just have a good estimation of the energy used for lighting, and also leading to a better and more efficient type of buildings. And there we have the movable sun shading and glare protection devices, and especially their control that must be taken into consideration. So we have an implementation of a procedure to rate typical dynamic sun shading and glare protection systems for vertical and horizontal facets, and this is quite a complex thing which has to be taken into consideration. The next thing which is also new in this revision of the standard is the lighting control. So this means that we take this into consideration to have a constant illuminance level. And this is especially more and more easy to make as with the new products on the level of LEDs. It gets more easy to just adapt the illuminance according to what is going outside, or how much daylight is available, and also what the need of the employees in the building is. That we can we can change the illuminance without changing the other things which are already taken into consideration within the design process. And with the lighting controls, we just take also into consideration the daylight situation, as I said, and also the occupancy dependent control, because let's say when the room or the zone where the activity is done is not occupied, then there's a good chance to just reduce the lighting level and just also gain some energy, or let's say just do not spend energy. So there we have to take into account the dimming characteristics of LED systems, and this is also part of this document, which is now under preparation. Next thing is also taking into account the system indicator. This means that we have we have to design and implement an energy-optimized general lighting system, and taking also the final net energy and energy demand. So what we have in the standard, this is what I would like to show you, is that we have established 3 methods. And so we have one method, this is the method 3, which is the method 3, which is, let's say, a method taking the metering into account. So this means that we just can see how much energy is used and how this is taken into control. And from this, we just have the possibility to see what type of lighting energy is used at any time, and then come to the LENI. LENI is the typical indicator for the energy used within the building, and so this is then now given here. And then we have 2 other methods. One method, the method 2, is a method which is, let's say, we say to it a quick method. It's a calculated method, and it is a method which is done at a stage where we do not know how the building is going to be. So let's say we have the situation that a building is in plan, and it is not yet known what type of work is done in this building. We don't know how the different rooms will be. So there we need just an estimation on how this will be done in the building. And so there we have the possibility to then make this quick method and gain some default data, which leads then to a preliminary annual LENI, just giving an estimation in which direction we are going. And based on this method 2, we will have the method 1, which is a calculated method and which will be much more detailed. And the idea there is that it is very important not only making the estimation, but also having a lighting design process incorporated in this method, so that you can know which zone you have, which type of visual task, and what type of luminaires and illumination is needed, and therefore this has to be done then more detailed, so that we can also give a good result, and which can be also good achieved. And last but not least, you can see here that for the lighting energy, I don't know where the mouse is. Here it is. But the lighting energy, it can be done based on annual, monthly, or hourly data. Although I have to say that, especially taking the lighting or exterior lighting, daylighting into account, it will be it will not be very easy to just say how the hourly type of exterior lighting will be, the daylighting will be, but nevertheless, we can take also there some assumptions and doing this. So I think at the end is our objective that we gain the LENI indicator, and we can give it, have it by 3 different types of methods to get this, and these methods are also according to the situation where we are just in that time. So I hope that I could give you some insight into our revision, and would like to thank you very much for your attention and open for further.